What if I told you that the next breakthrough in artificial intelligence isn't coming from bigger models or more data, but from a fundamental shift in how we think about intelligence itself? For years, the dominant paradigm in AI has been the transformer, deep neural networks that process information by assigning attention weights to every part of an input. It's powerful. It's vast. It's behind everything from language models to image generators. But here's the problem. Transformers are reactive. They don't understand causality. They don't reason. They don't know why something happens, only that it does. They're pattern-matching machines, trained on vast datasets. But when the world changes, when the ball rolls behind a wall or the dog suddenly stops, these models don't adapt. They hallucinate. They fail, because they lack a model of the world. So what if we could build AI that doesn't just predict, but understands? That doesn't just memorize, but reasons. Enter causal AI, a new frontier that's not just about better predictions, but about building machines that truly comprehend cause and effect. At its core, causal AI is built on a framework called causal inference, a mathematical language for describing how changes in one variable affect another. It's not just correlation. It's intervention. It's asking, what happens if we change X? This isn't theory. It's been rigorously formalized by Judea Pearl and others in the 1990s. But until recently, it's been confined to academia, too complex, too abstract, too hard to scale. Now, researchers are merging causal inference with deep learning. The result? Hybrid architectures that combine the pattern recognition power of neural networks with the reasoning strength of causal models. One of the most promising approaches is causal discovery, where AI doesn't just assume causality, but learns it from data. Instead of being told rain causes traffic, the system discovers it, by testing interventions, measuring dependencies, and eliminating spurious correlations. This is causal learning. It's like teaching a machine to ask, what if, not just what's next. In autonomous systems, this isn't just an improvement, it's a necessity. A car that only sees patterns might misinterpret a puddle as a hazard. But one that understands causality knows. Wet pavement right arrow, reduced traction right arrow, longer braking distance. It acts accordingly. In healthcare, causal AI can identify treatments that actually work, not just those that correlate with recovery. It can simulate what-if scenarios. What if we gave this drug to patients with this genetic profile without running risky trials? This is where the math becomes powerful. The do operator introduced by Pearl formalizes intervention. It's not P, Y, X, the probability of Y given X, it's P, Y do X, the probability of Y if we force X to change. This is the difference between observing that smokers get lung cancer and knowing that smoking causes lung cancer. And this is why causal AI is so transformative. It enables counterfactual reasoning, the ability to ask, what if I had done differently? Not just to predict the future, but to reconstruct the past. This isn't science fiction. It's already being applied. In robotics, causal models help machines learn from failure. In finance, they detect systemic risk. In climate modeling, they simulate the impact of policy interventions. But there's a catch. Causal models are only as good as the assumptions behind them. If you get the structure wrong, if you assume a cause is B when it's actually C that drives both, you'll get the wrong conclusions. And that's why causal AI isn't about replacing neural networks. It's about complementing them. The future isn't neural networks versus causal models. It's neural causal networks, systems that learn patterns and structure. That use deep learning to infer latent variables, and causal inference to reason about interventions. We're no longer building machines that mimic human intelligence. We're building systems that think like humans, not by copying behavior but by understanding the world. And that's not just a step forward. It's a paradigm shift. Because the next frontier isn't just prediction. It's understanding. It's causality. It's reason.